Good afternoon, everyone. Thank you for joining us. Welcome back. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yeah, and today we're talking about something that's not exactly in our backyard, but pretty close to home, which is kind of unusual. Normally we're talking about diseases or space or stuff across the globe, but this is Northern California. So kind of scary, but we'll talk about it, see what happens.
Scientists studying Northern California have uncovered previously hidden fault lines, raising alarms that seismic risk in the region may be underestimated. For decades, the Mendocino triple junction, let me throw that up on the screen here.
Yeah, it's a good picture.
There we go. Yeah.
Yeah.
So what's on your screen is you can see the fault line. It's partially in the ocean that comes up on land. And the triple is right at the crook. We're probably Eureka, California, right around there. That triple junction. Let me see.
And again, right on the coastline.
Yeah. Was believed to be where three tectonic plates meet: the San Andreas Fault, ending in the north, the Cascadia Subduction Zone in the south, and the Mendocino Fault in the east. Because three major fault systems converge there, the area is one of the most active earthquake zones in the U.S. and could produce a magnitude 8.0 quake. Would you like to know more?
Yeah, so and we've mentioned this before when we talked about earthquakes, but just to give you an idea, San Andreas Fault is within a half an hour's drive from here, where we live. Yep. And it could devastate.
It goes all the way up. It goes up California. It goes up California.
Yeah, exactly. And it crosses one of our major freeways, Interstate 15, if you're familiar with that freeway. So if it were to let loose, it would be devastating for our area. But anyway, we've always known about that one. A couple of these other ones we have, but not this new one. So we'll see. Now researchers have discovered that the junction actually contains at least 5 tectonic plates or fragments deep below the surface, making the region far more complex than previously thought. That means there may be an unaccounted earthquake hazard in the area, and current models could be underestimating the true risk.
5, that's crazy.
Yeah, that's not good.
Because the junction lies off the coast and influences both the San Andreas and Cascadia systems, revisions to the model could affect risk calculations for millions of people along the West Coast.
Yep. Scientists compare the new findings to an iceberg where most of the structure remains hidden below the surface. Geophysicist Amanda Thomas of the University of California, Davis, said, if we don't understand the underlying tectonic process, it's hard to predict the seismic hazard.
That's an understatement.
Yeah.
This discovery shows that the underground fault structure is more complicated than scientists thought. If the models don't include these hidden faults, they underestimate how much stress is building up underground. That means a larger earthquake could happen unexpectedly, because the hidden faults could suddenly release energy in ways the old models didn't predict.
Yeah. The team suspected something more complex was happening at the Mendocino triple junction, as a large magnitude 7.2 earthquake in 1992 occurred at a much shallower depth than expected. Again, I don't know. I'm not sure how they figured that out, but it's fascinating that they are able to do that.
Probably triangulate sensors, and then boom, they can figure it's that deep.
Yeah. Good for them. I'm glad that there's people on this kind of stuff. So first author, David Shelley of the U.S. Geological Survey Geologic Hazard Center in Golden, Colorado, said in a statement, "You can see a bit at the surface, but you have to figure out what the configuration is underneath." So it's kind of a guessing game, right? These guys are.
And this David Shelley is no relation to the Frankenstein author Shelley, Mary Shelley, right?
Okay, I hope not.
Okay. Using a network of seismometers in the Pacific Northwest, the team tracked tiny, low-frequency earthquakes deep underground where tectonic plates grind and slide past each other, kind of like on the dance floor. These events are far too weak to be felt on the surface, thousands of times smaller than a detectable quake. To verify the results, the team compared the seismic activity to tidal forces.
The sun and moon's gravity pulls on the Earth's crust just as it does on the oceans. When those forces align with the direction a plate is moving, the researchers observed a rise in small quakes. This is according to Thomas, confirming their model. The new model reveals that the Mendocino triple junction is not just a three-plate intersection, but a far more complicated system of 5 moving pieces, 2 of which are hidden deep below the Earth's surface. So I wonder why they don't call it the 5-way junction.
Well, they probably do now. This is fascinating. We always think of, the moon affects tides, and it pulls the tides, and that's why the tides rise. But we never think about the crust.
Yeah.
It's got to be the same thing, right?
I guess so. That's
maybe not as dramatic like a several feet rise, but maybe a couple inches or a couple centimeters.
Yeah. Never know.
At the southern end of the Cascadia Subduction Zone, researchers say a chunk of the North American plate has snapped off and is being pulled down along with the Gorda plate as it sinks beneath the continent. Further south, the Pacific plate is dragging a massive rock called the Pioneer Fragment northward under North America. The fault between the Pioneer Fragment and the North American plate runs almost horizontally and is completely invisible from above ground.
The Pioneer Fragment is a remnant of the ancient Farallon plate, which once ran along California's coastline before mostly disappearing. The updated model also explains the unusually shallow depth of the 1992 earthquake because the subducting surface lies much higher than previously thought. This is according to Materna. I don't know if we mentioned it.
And we'll continue a quote here. It had been assumed that faults follow the leading edge of the subducting slab, but this example deviates from that, Paterna said. The plate boundary seems not to be where we thought it was.
Yeah, that's scary stuff, right? I mean, they're watching this area, and then the plate or the shifting starts happening someplace else, and then it's like, oh well, we've got another plate or another quake or another fault line.
Seems to be right around Eureka, that area.
Yeah, Northern California. So yeah, watch your back.
I'm sure the Bigfoot they experience this all the time. They know what's going on.
Yeah, they probably sense it long before man, or way before man does, right?
Yeah. All right, folks. Thanks for joining us. We'll see you in the afternoon.
Take care, everyone. We'll see you this afternoon. Thanks.